Chapter 21 Introduction to Organic Chemistry. There are three parts to this chapter: 21.1 Organic Compounds, 21.2 Petroleum and Natural Gas, 21.3 Competing Uses of Petroleum. Now in 21.1, the key thing we need to learn is what is a homologous series. Before we start, what are organic compounds? All organic compounds contain carbon. Most organic compounds also contain hydrogen. And very important, the definition of hydrocarbons. Hydrocarbons are organic compounds that contain only hydrogen and carbon. Some organic compounds may also contain oxygen and chlorine and even nitrogen, but they are not hydrocarbons because hydrocarbons contain only hydrogen and carbon. So now, what is a homologous series? To study different organic compounds, related organic compounds are grouped into families called homologous series. So this definition is very important. Please remember that. A homologous series is a family of organic compounds with the same functional group with similar chemical properties. In other words, they react similarly. You need to study four families, which is also the four homologous series: alkanes, alkenes, alcohols, and carboxylic acids. These are the only four families that you need to know in detail. What is a functional group? This definition is also very important. Please remember, a functional group is an atom or a group of atoms that gives a molecule its characteristic properties. In other words, the property of that particular molecule depend on the functional group. Any molecules having the same functional group, they react similarly. And the fourth family you're going to study, alkane, alkenes, alcohol, and carboxylic acid. These are the respective functional groups you must remember. For alkanes, there's no special functional group. That's the reason why alkanes are the least reactive among them. As for alkenes, there's a carbon-carbon double bond. Take note how you draw the carbon-carbon double bond, as well as write the exact words when you are being asked. So carbon-carbon double bond is spelled as carbon-carbon double bond. Alcohol has this hydroxyl group, which is the -O-H. This is not the same as OH-. It is not OH-. That's called hydroxide. This hydroxyl group is neutral. Learn the spelling hydroxyl. Carboxylic group. There's a COOH group. And this is spelled as carboxyl group. What are the general characteristics of a homologous series? In the same homologous series, they must have the same functional group. And because of the same functional group, they have similar chemical property. And this property can vary from less reactive to more reactive and so on. And it shows a gradual change in their physical properties down the series. In other words, down the series means as the molecules become bigger and bigger, there's a gradual change in the physical properties. So let's try this question. Which of the following statements about homologous series are correct? Answer is: all members undergo similar chemical property? Yes. They have same functional group? Of course. Because of the same functional group, they have similar chemical reactions. But do they have the same physical property? No. So answer is actually A, 1 and 2 only. Naming organic compounds. The name of an organic compound is divided into two parts. The prefix, which tells you how many carbon atoms are there in each molecule. There's a Me represent 1, E 2, Prop 3, and Bute 4. And of course there are a few more. 5 is pent, 6 is hex, 7 hep, 8 is oct, 9 is non, and 10 is dec. You only need to know the first 4 for O-level syllabus exam. So the suffix, What follows after the number of carbon is the homolog series. For example, in a homolog series of alkane, the name ends with A and E. So if we have one carbon, it's called methane because me is one carbon. And ethane means two carbon. For alkene family, it always ends with E and E, and because there are two carbon, so it's called ethene. Alcohol family ends with ano. Take note, it's not just O but ano. So if two carbon means ethanol. And for the carboxylic family ends with anoic acid. So the prefix is two carbon means ethanoic acid. Okay, let's try. For 3 carbon alcohol, 3 carbon alcohol, what the name should be? 3, if you look from the previous slide, it is prop, P-R-O-P, and followed by ano, so it's called propanol. So a 3 carbon alcohol will be called a propanol. The first part is the number of carbon, the second part is the name that comes with the family. And if you look at this example, 3 carbon alkene. Because of a carbon-carbon double bond, this must be from the alkene family. And since the 3 carbon is called propene. Okay, let's try this. So methanoic acid. E for ethanol, and ethanoic acid. Propene, propanol, and butanol. Realize that for the same number of carbon, the prefix must be the same. So 4 carbon is all BUT, 3 carbon is all prop, and 2 carbon is E, 1 carbon is me. Now why is it there's no alkene with 1 carbon? Because alkene must have a carbon-carbon double bond. So with a carbon-carbon double bond, the minimum number of carbon must be 2. Next, we come to the petroleum and natural gas. So by the end of this session, you should be able to describe petroleum as a mixture of hydrocarbons, and name natural gas and petroleum as a source of energy, and describe fraction distillation of petroleum. And also you must know how to name the fractions and their uses. Petroleum and natural gas are used as sources of energy. So how are they used as sources of energy? They can be burned to produce heat, light, and so on. So you must know one thing very importantly in this section is that petroleum is a natural occurring mixture of hydrocarbons, which is mainly alkanes. Petroleum is also called crude oil. Natural gas is made up of mainly methane, which is about 70 to 90%, and other alkanes. How petroleum and natural gas form? It's actually formed from millions of years of chemical reaction. So let's look at this. Sea creatures and plants sink to the seabed when they die. That was millions ago. Over millions of years, these organisms are subjected to heat from earth and pressure. Petroleum and natural gas are formed, and deep wells are drilled to get them out. So, now that you have understood how natural gas and petroleum were formed through millions of years of chemical reactions, they are hence classified as fossil fuels. Suggest one characteristic of a fossil fuels. Fossil fuels are non-renewable sources of energy. So let's take a look at renewable and non-renewable. Renewable energy is generally classified as energy that is collected from resources that are naturally replenished in our lifetimes. For example, sun, wind, rain, waves, tidal, and so on. All this energy, when they're used up, they can be replenished. Now, non-renewable energy cannot be replenished in our lifetime or even in many lifetimes. In other words, once you use up, we are not able to make it out again. So non-renewable energies are referring to coal, petroleum, natural gas. All these are also considered as fossil fuels because they are not renewable and they are actually fossils. Carbon is the main element in fossil fuel. Which of the following statement about natural gas is correct? Answer is 3. It contains mainly of methane gas. Petroleum can be separated into useful fraction by fraction distillation, and this part is very important. Each fraction is also a mixture of hydrocarbon which boils over a certain range of temperature. How do you know that each fraction is still a mixture? Because it boils over a certain temperature range. The lighter fractions containing a fewer carbon atoms has a lower boiling point than a heavier fraction. So lighter fraction refers to smaller molecules. Now in this fractionating column you see, petroleum is first heated into vapor inside this furnace and passed into the fractionating column. The hot vapor cools and condenses as it rises up. The temperature is lowest at the top, highest at the bottom. Lighter fractions with lower boiling point are collected at the top of the column as gases. Heavier fractions with higher boiling points are collected at the bottom of the column as a residue. Please remember the 7 fractions. First, petroleum gas, petrol, naphtha, kerosene, diesel oil, lubricating oil, and bitumen. The position is very important. Please remember them. Which statement about the fractional distillation of petroleum is correct? Answer is D. First of all, liquid petroleum is not pumped into the column. Liquid petroleum is boiled and passed into the column. Petroleum fraction collected at the top has to be the smallest, not the largest. And petroleum fraction collected at the bottom is the highest range of the boiling point because they are bigger molecule, higher boiling point collected at the bottom. Each fraction is collected as a mixture of compounds, correct? Because each fraction itself is still a mixture and they boil over a range of temperature. So let's look at the uses. Petroleum gas are used as fuel for cooking and heating. Please do not forget to write the word fuel. Please do not write petroleum gas is used for cooking and heating because you do not cook the gas to eat. Likewise, petrol is a fuel for vehicles. Naphtha is a feedstock for petrochemical industry. What is a feedstock? Feedstock refers to raw material. Raw material. So they can be used to make plastics and so on, or even medicine for petrochemical industry. So petrochemical refers to petroleum chemistry. Okay, they can make plastics and medicine. Kerosene can use as a fuel for aircraft engines or cooking or heating. And diesel oil is fuel for engines in buses, lorries, and trains. Lubricating oil is used to lubricate machines or make waxes and polishes. And last but not least, bitumen for paving road surfaces or for roofing. So it's increased friction between the tire and the road surface. Which of the following petroleum fractions is correctly matched to its uses? Simple, right? Answer is lubricating oil to make polishes and waxes. Last section, competing uses of petroleum. In this section, you'll be able to describe the issues related to the competing uses of petroleum. Competing uses means there are many different users competing for the petroleum. For example, in this case, you can see that 90% of the petroleum is used as a fuel, while 10% is chemical feedstock. And this chemical feedstock make us very useful materials, for example, plastics, detergent, medicine, fertilizer, pesticides, and even synthetic rubber. The eraser that you use that can stick together, those erasers are actually made from synthetic rubbers, which is actually petroleum product. Now you realize that 90% actually is burned away to produce energy, to power cars, to power industry, and so on. If we continue to burn away all our petroleum, one day we realize there's not enough petroleum to make plastic and so on. So how? So we know that first of all the issue is petroleum is a non-renewable resource. And because it's non-renewable, its supply is limited. Once you use up, there's no more left. So to meet the two competing uses of petroleum, there's a need for its conservation. Conservation is an act of trying to protect or preserve something for it to last longer. So if we can conserve our use of petroleum, it may last more generations to come. If we do not conserve them, perhaps in the next 1 or 2 generations, once petroleum is used up, then we run out of fuels, we run out of material for making plastics and so on. So how do we conserve petroleum? We can reduce the number of motor vehicles on the road by taking public transport and drive cars that consume less petrol. Also improve the design of power station and vehicle for more efficient use of petroleum. Or better still, we use alternative energy sources such as solar energy and nuclear energy. But we know that using nuclear energy, even though it can produce a lot of energy, there's a high risk. If the nuclear power plant has any incident, it can be very deadly to a small country like Singapore, because there's no way you can escape the radiation. And of course, solar energy is a very good alternative kind of energy, or you can even use alternative fuels. So what are alternative fuels? It refers to biofuels, biogas. So biogas produced when dead plants or animals decay in the absence of air. So this is basically the composition of biogas, mainly methane, about 50 to 75% methane, and some carbon dioxide also. Biodiesel is made from plants like palm oil. How about gasohol? Gasohol is very interesting because it's a mixture of ethanol and petrol. We know petrol is non-renewable, it's a fossil fuel, comes from petroleum. But ethanol can be made from fermentation of sugar from sugar cane. And sugar cane is a renewable source of energy because it can be grown again and again. As long as there's sunlight, there's water, sugar cane can be grown to produce ethanol through fermentation. So gasohol, which is a mixture of ethanol and petrol, is a very good alternative to using purely petrol alone.